scenario, unmask the interrupts in the condition code register. Now that we have reached that step, what have we accomplished? We have already opened the two double doors. We opened the two doors. We are ready to receive interrupt at any moment right now. The interrupt can take place any moment without any hesitation or reluctance from your system. Then you have to do some initialization for port B. You want to declare something as an output or an input. So let's see. B set data direction register B bit number 4. This is bit 4, by the way, because the rightmost one is bit 0, 1, 2, 3, 4. This is bit number 4. So port B line 4 is declared as an output. This is data direction register B. And then you want to declare, you want to clear port B itself. This is the data register. One of them is the data direction register, and the other is the data register. So the data direction register, we've declared one of the bits to be an output bit. The data register, we've already assigned number 1 to line number 4 on port B. All right. Look at that. I would like you to look at this instruction. Bit clear port B, and there is a percentile sign. What does that mean? It means that port B line 4 is 0. Port B line 4 is 0. Okay, so because you're clearing bit B, and this percentile means this is a binary representation for the bits of the data register of port B. So bit 4 is 0. 0 means you're gonna make the lid off. It could be one of those lids off. It could be this one here in the middle. This is line 4. It's eventually port B line 4 is this. You make it off. Make it 0 means the light emitting diode is going to be off. All right. That's what it is. And then this is all the initialization that you need. You already declared the port as an output port. You declared the initial status of the port, and you declared what kind of an interrupt we're talking about, right? It's an unmasked. This is level triggered.
It's level triggered, or?
Yeah, that's level triggered. Yeah. And you're dealing with the interrupt request pin. You're dealing with the maskable interrupt, let's put it this way. You're not dealing with the unmaskable interrupt. You're dealing with the maskable interrupt. All right, so where are we? We are here. We accomplished up till here. 1, 2, 3, 4, 5, 6, 7. 7 lines are good. We are in agreement here about these 7 lines. How could this question be on the final exam? Are we going to see something like this on the final exam? Yes, it's very possible that you see something. As a matter of fact, the final exam is going to have 7 or 8 questions. Four of the questions are going to come to you like printed pages like this, and all you're asked to do is make some little modifications to them. So you are going to do some slight modifications, and instead of asking you to rewrite 20, 30 lines of code each time, and I don't know which line I should look at, all I'm going to ask you is look at this and make the appropriate changes, and then maybe you need to copy this in a separate page, but you need to underline or make it in red color the important changes that you made. So for example, in the final exam, and I could say, okay, and instead of using port B, yeah, and instead of using line 4 of port B, who knows, maybe I could ask you in the final exam, let's make port B line 5. So you are being tested. What should we do here if it's line 5 instead of line 4? So what should happen to this line here? You're going to make the appropriate change here.
We move one to the left, one step.
Yeah, exactly. You're going to move this one probably one place to the left. You could be also tested on the
Edge trigger.
The interrupt control register here. Maybe I would ask you to play with the edge triggering. Yeah, maybe I will ask you edge triggering instead of level triggering. You see what I mean?
Would you put it as B clear?
No,
I'm
we
sorry,
can put
could you put it as
one
what?
ahead of 0. We start from 1 and then we put the rest of them 0.
You're gonna play with the two most significant locations, basically.
Oh, yeah, that's right.
Yeah, the other locations are all zeros in all cases. Yeah.
Right.
So we come to this, then you're gonna say branch here and the label is here. What does this do here? If you say here, branch here, that means do nothing. Wait. Keep doing nothing. Right? Does everybody see this? When you say here, this is a label. This here is a label. Branch here, this here is a destination or an operand. Here, branch here, that means keep doing this forever, means do nothing. All right. Once you see this do nothing instruction, that tells you that we are waiting. We are in anticipation of something to happen. What is it that we are anticipating to happen? An interrupt, right? Does everybody follow?
Yes.
Yes.
We are waiting for an interrupt. All right. How does the system know that there is an interrupt? You know, some
Make a
people,
subroutine.
yeah, some
Because
people.
we opened the two doors, right?
Yes, some people, and I don't blame them. They not able to connect. Where is the connection between the hardware and the software gonna take place? Okay, how is the interrupt gonna happen, and how is the interrupt gonna change control from here to somewhere else? Well, you've already configured the machine. By doing this, by configuring the interrupt control register, you already declared the kind of interrupt and whether it's edge triggered or level triggered. And you've already unmasked it. You've already gave the green light for the interrupt to happen. So that means you've already set the machine. The machine is all set. It's ready for the only thing left is that the hardware interrupt physically or actually happens. And as soon as it's going to happen, the machine software is going to change accordingly. So you don't have to worry about that connection. This connection is already built in. The mere fact that you've already configured the machine using those statements means that when the interrupt takes place, the sequence of events are gonna happen how? Let me go to that page. I'll go to that page again and explain 11.7. That page, that's gonna happen. See? So the instruction that we are executing now is here, branch here. Look at that.
I have a question though.
Yes.
For that the example that we were looking at, don't we
Yeah.
need to put a LDS there to load a stack pointer first, or no?
Yeah, why not? Yeah,
Right.
you need to.
Yeah, we
Yeah.
need to, right? Because
Yeah.
in order for us to push in the
Yeah.
memory address.
And in order to avoid ambiguity, you need to know, you need to make sure that the stack is properly working.
Yeah.
You need to select